Welcome to the mysteries of the cosmos. The arrow of time is a fascinating concept that describes the seemingly unidirectional direction in which events flow in our universe. This fundamental phenomenon raises an intriguing question: why do we experience time as always moving forward and never backward? Unlike space, where we can move freely in any direction, time seems to have a fixed and irreversible direction. This temporal asymmetry is evident in our daily lives. We can remember the past, but not the future. We see objects break, but they never spontaneously reassemble. The arrow of time manifests itself in various aspects of physics, each offering a unique perspective on this cosmic enigma. The thermodynamic arrow of time is perhaps the best known, based on the second law of thermodynamics and the concept of entropy. Entropy, a measure of disorder in a system, tends to increase over time in closed systems, providing a clear direction to the flow of time. This principle explains why it is easy to mix paint of different colors, but impossible to separate them once mixed without external intervention. The psychological arrow of time refers to our subjective perception of the passage of time and our ability to distinguish between past and future. Our memories are formed and stored in one direction, creating a sense of personal history that flows from the past to the future. The cosmological arrow of time is related to the expansion of the universe, which provides a clear direction from the Big Bang into the future. This cosmic expansion creates a fundamental asymmetry in the history of the universe, clearly distinguishing between its compact past and its expansive future. The quantum arrow of time emerges from quantum mechanics, where the act of measurement introduces irreversibility into previously reversible systems. The collapse of the wave function during a quantum measurement creates a distinctive before and after, contributing to our perception of the flow of time. The electromagnetic arrow of time is observed in electromagnetic radiation, where waves expand into the future but do not contract from the past. This behavior of light and other electromagnetic waves reinforces the apparent direction of time in our observations of the universe. The causal arrow of time refers to the sequence of cause and effect that we observe in events, where causes always precede their effects. This unidirectional causality is fundamental to our understanding of the world and appears to be deeply rooted in the structure of the universe. The paradox of the arrow of time arises when we consider that the fundamental laws of physics are largely reversible in time. At the microscopic level, many physical equations work the same forward or backward in time, in contrast to our macroscopic experience. This discrepancy between the time symmetry of physical laws and the asymmetry observed in the real world is a subject of intense scientific debate. Some physicists argue that the arrow of time could be an emergent property, arising from low-entropy initial conditions in the early universe. The baby universe hypothesis suggests that our cosmos began in an exceptionally ordered state, setting the stage for increased entropy. This idea connects the arrow of time with cosmology, proposing that the direction of time is intrinsically linked to the evolution of the universe. The concept of blocked time and relativity challenges our perception of a flowing time, suggesting that past, present, and future coexist. In this view, the arrow of time might be more a feature of our consciousness than a fundamental property of the physical universe. Black hole thermodynamics, developed by Stephen Hawking and others, has provided new insights into the nature of time and entropy. Black holes appear to represent states of maximum entropy, potentially offering clues to the ultimate fate of time's arrow. The idea of time reversal in quantum systems has been explored experimentally, showing behaviors that appear to defy the arrow of time. These experiments, although limited to microscopic scales, suggest that the irreversibility of time might not be absolute at all levels. The arrow of time also has profound philosophical implications, questioning concepts such as free will and the nature of reality. If the future is determined by the past, how do we reconcile this with our sense of making free choices and affecting the course of events? The block universe hypothesis proposes that all moments in time exist simultaneously, and our perception of temporal flow is illusory. This view challenges our intuition, but it could resolve some paradoxes related to the nature of time in modern physics. The search for a unified theory of physics could provide new insights into the arrow of time and its fundamental origin. Some physicists speculate that a theory of quantum gravity could reveal the ultimate source of the time asymmetry we observe. The connection between the arrow of time and the complexity of the universe is an active area of research in physics and cosmology. It has been proposed that the increase in cosmic complexity could be an alternative manifestation of the arrow of time, parallel to the increase in entropy. The possibility of islands of time reversibility in an expanding universe has been theorized, suggesting regions where time might flow differently. Although highly speculative, this concept illustrates the complexity and potential surprises that might still exist in our understanding of time. The arrow of time also relates to the problem of structure formation in the universe, from galaxies to life itself. The tendency toward increasing entropy seems to contradict the formation of complex systems, a puzzle known as the Loschmidt problem. Resolving this apparent contradiction between increasing entropy and the evolution of complexity is a central challenge in modern physics. The arrow of time raises fundamental questions about the nature of the universe. Is the flow of time an illusion or a fundamental property of reality? As we explore these questions, we come closer not only to a better understanding of time, but also of the very nature of the cosmos. The study of the arrow of time continues to challenge our intuitions and push the boundaries of theoretical and experimental physics. Understanding why time flows the way it does could be key to unraveling some of the deepest mysteries of the universe. Thank you for joining us on this stellar journey. If you enjoyed this cosmic tour, don't forget to like the video. Subscribe to Mysteries of the Cosmos for more space adventures. See you in the next video.